So, here are their examples. Chemicals then are substances that have the same composition and properties wherever you're found. So, is water a chemical?
Yes.
Yes, it is. Absolutely. Okay. Most things could also be classified as chemicals. I don't like the word chemical because it has a very negative connotation to it, doesn't it? When you think of chemicals, you think of that smell when you walk into the what do you call it now? The salon, right? Is that what it's called now? It's not called a beauty shop anymore, is it? What is it called? The salon. Your stylist.
Yeah.
When you walk into the stylist's office or a place of business, that smell, that's what you think of when you need chemicals, right? But not all chemicals are like that, are they? Anybody ever use any chemicals? Every day. You drink water, don't you? You eat food, don't you? Who cooks? You're doing chemical reactions when you cook. Great chemical in the kitchen is baking soda. You can do all kinds of stuff with it. It's really fun to play with in the lab sometimes too, right? Okay? So there's lots of chemicals. I don't like that term. And actually, their example coming up is toothpaste. Anybody ever looked at the label on the toothpaste box? Or better yet, healthcare products or health and beauty products are amazing with the stuff that's in them. You should read the label sometime. You'd probably be so scared you might not ever use them again. They're really disgusting sounding, okay? So their example is, here's a lot of the stuff that's contained in toothpaste. Look at some of this stuff. Sodium lauryl sulfate. Ugh. That's also one of the primary ingredients in soap, by the way.
Oh, lovely.
Yeah, well, you got to clean them pearly whites, don't you? Why should you clean them differently when you clean your hands, huh? How do you make it taste better? You put a little methyl salicylate in there. Give it a little wintergreen flavor. Overcomes the taste of the soap, right? So you got to mix them all together. So there's all kinds of things that they mix in there. Some of them sound pretty disgusting. Triclosan. Titanium dioxide. You're eating a bunch of metal, aren't you? Yeah. Huh? Makes your teeth white. That's right. Sounds kind of nasty. Are you doing all this to my teeth when you're doing hygienist? You're going to put all that in my mouth?
Yeah. A lot more too.
Yeah, exactly. Right? Nasty. No. In very low dosages, like if you were just to go out and eat a bunch of titanium dioxide, it probably wouldn't be very good for you. Okay? If you were to eat a truckload of sodium fluorophosphate, I know it wouldn't be good for you. But in small dosages, they do certain things for you that you need, right? Okay? So we take advantage of that, and there are chemists that work on formulations with it. Here's another example. Here's in the kitchen. In the other section, right? Y'all know I teach another section that starts at 1, right? So this is the second section. We talked about the apples on there, right? They're examples for how chemists were involved in this. Is the fruits were grown with fertilizers and pesticides. Is there anything else that you can think of that a chemist might have had a hand in with that bowl of apples right there? It's the apple itself.
The glass.
Not the bowl, but the fruit. The what?
The tree.
The tree, probably. There may be a chemist involved in, the genetics of the tree, trying to improve it.
Not the wax on that.
That's the example I used in the other class. The wax on it. Look how shiny those apples are. Did the apple come off that tree and it was that shiny?
No.
Heck no. Who's ever bought an apple at a farmer's market? They don't look anything like that, do they?
No.
They're dull. Normally got a blemish on one side or something, right? Because that's what an apple really looks like. Those ones in the store, what do? They scrub them down and then they spray them with wax. And they buff them. Make them all shiny. So when you go in, ooh, look at that shiny apple. That's the one I want. No, that's the one that's been waxed up the best, right?
It's a form of preservative, right?
Yeah, it normally contains a little bit of a preservative as well, yeah. To keep them from rotting so fast, right? And so chemists also work on formulations for compounds that allow you to ripen fruit and vegetables at the right time. So when I lived in Tallahassee, I remember I was driving down the road one day. I looked over. There's this big truck, like an 18-wheeler. It had, one of the big things on the back, and it was full. And I looked up. I said, "Man, there's a whole truckload of green apples. Man, I could really use an apple." And I started thinking, I'm like, "Wait a minute, it's North Florida. There's not an apple tree within a couple hundred miles of here, probably. Apples don't grow well in North Florida. It's too hot." Okay. I said, "What the heck was that? What do you think it was?"
GMO?
No. What was it?
Green tomatoes.
It was green tomatoes. They had just, there was a whole truckload of green tomatoes. They weren't going to take them home, bread them, and fry them, I can tell you that. What are they going to do? They're going to take them, wash them, spray them with some stuff, ship them off to the market, and hopefully they treat them with just the right stuff so that in about a week's time, they'll ripen in the grocery store. Right? It takes about that amount of time to ship them around the country. Between the time they pick them and the time they get to the grocery store, it's probably 4 to 7 days. You don't want to pick them when they're already ripe. Why? Because in 4 days' time, when it gets to your grocery store, it'll just be mush, right? So there are chemists that work on that type of thing. Okay? Does that make sense? Mm-hmm. So they have lots of other examples on here as well. So we'll make this one easier. Here's how we do things in this class. This is a poor man's clicker system. If you want to vote for A, you hold up one finger. For B, you hold up 2. C, you hold up 3. D, you hold up 4. Okay? You can also, we are democratic. You can exercise your right not to vote by not voting at all. Okay? That means you got no clue. We're going to modify this question. It says, which one of the following contains chemicals? I'm going to ask you which one of the following does not contain chemicals. Think about it for a second, and then we'll vote. Everybody see it? Which one of these does not contain any chemicals? 1, 2, 3, vote. You should hold up one finger, right? Because sunlight doesn't have any chemicals. It's a form of energy, right? There's no chemicals there.
What about vitamin D?
Not sunlight. There's nothing in sunlight. It's energy.
Oh, okay.
When it hits your body, it helps you manufacture vitamin D, right?
Oh, okay.
But there's not any vitamin D in sunlight. So, moving right along. This guy was like, when I was in college, a few years back, in the 80s, I know that's a long time to some of you. This guy was like famous. He died in the 90s. He was pretty old. This guy's name Linus Pauling won a Nobel Prize. Y'all all know about Nobel Prizes?
Yeah.
Probably the most famous one is the Peace Prize, right? A lot of people recognize the Peace Prize. But they also give them in chemistry, physics, medicine, literature, economics. Can't remember what else. And peace. So there's like 7 or 8 categories. He won one in chemistry in 1954. One of the great minds of the 20th century, Linus Pauling. He's also famous because he's one of 3 people in history to have won multiple Nobel Prizes. Anybody know what he won his second Nobel Prize for?
Physics?
No. He liked to read, but he didn't write. Well, he wrote research articles. He won a Peace Prize. He became an anti-atomic weapons advocate. He would travel the world speaking against the use of nuclear weapons. So he won a Peace Prize in the 60s. Who else has won multiple Nobel Prizes, ladies?
You.
I wish. If I had done that, I wouldn't be here. Who? No. No. I never won a Nobel. Ladies, that was a hint. A lady.
I know her, and she was like one of the
Marilyn Monroe.
Oh, Mother Teresa.
Mother Teresa. She won a Peace Prize, but she never won it more than once.
She was a
Ellen
physicist,
Keller?
wasn't she? I can't remember her name though.
She was a what?
She was a physicist,
Oh,
wasn't
She
she?
was a physicist / chemist.
Marie Curie.
Marie Curie, yes.
God, look at that.
She and her husband worked together in the lab, right? Worked on the fundamental properties of radioactivity. Okay. And she died at a relatively young age of Radiation
Radiation
poisoning.
exposure.
Yeah, kind of sad. It's a terrible way to die, evidently. And so she won one Nobel Prize in chemistry and one in physics. And then there was a guy that died last year, I believe, that won 2 prizes in chemistry. He won both of his in chemistry. And I don't even remember his name. So, but I mean, I'm sure eventually he will be written into the books and stuff, but he was very much a recluse. Like, he didn't go out and see. I mean, a lot of these people, they become famous, they could travel the world giving speeches and stuff, right? This guy didn't. So that's why a lot of people don't know who he was. So, but anyway, so he was one of the great minds of the 20th century. How did he do his work as a thing? So let's talk about scientific method for a minute. The scientific method is made up of several steps. The first one is you must make an observation. Okay? So the second step is, from that observation, you're going to form a hypothesis. And that's a possible explanation of your original observations. And something they don't have on here is it must be testable. You must be able to test your hypothesis to see if it's true or not. Okay? And then you're going to perform some experiments to test that hypothesis. And then if they hopefully lead you someplace, you will come to some sort of conclusion. So in the other class, I can't remember what people want to do in here. I got to ask this question. Who wants to be a vet tech that's in this class? So most of you. Okay, so I'll use some vet tech examples. How's that? Same thing would apply if you want to be a nurse, just insert person instead of dog. Okay? Let's say Susie brings her dog to see you. And what do? What do you do when Susie brings her dog to see you?
Observe the illness.
You observe the illness. You ask questions, right? And those are your initial observations. Okay? From those initial observations, you will make a hypothesis. So let's say that, what did I say her name was that brought it? Susie brings in her dog, and you weigh the dog, you look at the dog, you notice he's not acting like, doesn't have any energy, you ask her some questions, and it turns out that Susie also has a little boy that loves to play with Legos, and he leaves them out all the time. So what might be your hypothesis?
Don't eat Legos.
The dog is eating Legos, and it's upsetting his tummy. That's a good hypothesis, isn't it? Seems kind of logical, doesn't it? Here's some observations I made. Susie had a dog was happy. Johnny left out the Legos. Looked like there might have been a few missing, and now the dog's not acting right. Can we test that hypothesis?
Yes.
How are we going to test it?
X-ray.
We're going to shoot some radiographs, right? And
Stool sample.
if he passed them, he probably would be feeling better by now, right? You could wait and collect a stool sample and look for Legos.
It's on his belly.
You take a radiograph of his tummy, and then if that's what it is, you come to a conclusion, right? You go, hey, look, there's Legos in his belly. My hypothesis was right. I got a conclusion. What if you don't see any Legos in his tummy when you shoot those radiographs? Well, your hypothesis was wrong. And you have to make some more observations, and maybe you'll form a new hypothesis. Maybe it was something he ate, but just didn't show up on a radiograph. You don't know, right? You're constantly refining what you think until you try to figure it, until you get a very good.
Sorry,
Hello.
it's my alarm. I forgot to turn it off. Sorry.
Wake up. Okay? You see how that process can develop into a loop, right? Where you're constantly making observations and doing experiments to test what your hypothesis was. If it's true, then maybe to a conclusion. If it's not, well, then you've got to make more observations to develop a new hypothesis all the time. Okay? It can become quite old and tedious. You may go through hundreds of those loops before you ever come to the right one. Anybody here watch House?